Imagine it's Halloween week, 1999. You are sitting in the CEO's chair at Hershey.
Oh,
Right. In your warehouses across the country, you have like $100 million worth of chocolate just sitting on pallets. Kids are getting their costumes ready. Retailers are basically screaming for their shipments. And your fleet of trucks they're just sitting idle. They aren't moving at all.
yeah, a total gridlock.
Exactly. And why? Because of the multi-million-dollar state-of-the-art enterprise software system you just bought and installed literally forgot how to ship a candy bar.
It's just wild to think about.
It really is. The system, it just cannot process the orders. So the candy melts, your quarterly profits drop by 19%, and your stock takes an 8% nosedive, all because of a software rollout.
I mean, it is the ultimate corporate nightmare. And the truly terrifying part is that it isn't an anomaly. I think we tend to view these massive software gridlocks as rare, black swan events from the dial-up era.
Like it's just a Y2K thing.
Right, exactly. But that Hershey disaster is playing out right now, today, in boardrooms and warehouses all over the world. We are looking at a space where the world's most sophisticated technology consistently, and I mean violently, collides with fundamental human stubbornness.
And that collision is exactly what we are unpacking in today's deep dive into the architecture of deployment gridlock. Welcome, everyone. Today we are looking at a staggering paradox: the enterprise resource planning industry. So the ERPs that act as the digital nervous systems for global corporations. It's a $73 billion market.
Massive.
Massive. And it's projected to hit over $157 billion by 2033. Yet it delivers a product that has a 55 to 75% failure rate.
Which is just an unbelievable statistic when you really sit with it.
Think about that for everyone listening. If you bought a car for your daily commute and it only started 30% of the time,
You had to return it immediately.
you wouldn't just return it, you would sue the manufacturer. But executives, they don't return the car. They pour millions more into it. They hire armies of consultants to figure out why the engine won't turn over, while the people actually trying to drive the car are just left completely stranded.
It is the absolute definition of a trillion-dollar blind spot. And to diagnose why these catastrophic multi-million-dollar failures happen, we are going to apply a very specific and maybe kind of unexpected analytical lens today.
I really love this approach.
Yeah, we are going to look at enterprise software through the physical design philosophy of Dieter Rams.
Dieter Rams,
Yeah.
the legendary industrial designer behind Braun in the mid-20th century.
That's the one.
The man whose work heavily influenced the physical technology we hold in our hands every single day. I mean, Apple's early design language was basically a love letter to Dieter Rams.
Exactly. His core philosophy is encapsulated in the phrase, less but better. Rams advocated for functional clarity, visual order. He believed in the absolute ruthless stripping away of any non-essential clutter. We usually apply his principles to physical objects, right? Like a beautifully simple calculator, a radio with intuitive dials, a perfectly constructed chair.
But today, we are taking Rams's physical design principles and applying them to the invisible, highly complex architecture of enterprise software. Because when you comb through the research from Gartner, the Panorama Consulting reports, and the deeptech analysis of architects like Prasad Bond, a pattern emerges.
A very clear pattern.
Yeah, these software failures are almost never failures of code. They are catastrophic failures of organizational design.
The statistics are, they're sobering. The widely cited industry analyses, including data from Gartner, indicate that up to 75% of ERP projects fail to meet their intended objectives. Gartner even predicts that by 2027, more than 70% of recently implemented ERP initiatives will fail to fully achieve their original business goals.
I was looking at the Panorama Consulting Group's 2025 ERP report, and they segment this by industry. In discrete manufacturing, the failure rate hits 73%. And maybe we should define that for a second because the term gets thrown around a lot.
Yeah.
How does discrete manufacturing differ from other types, and why is the failure rate so uniquely high there?
So think of it this way. Process manufacturing is like baking a cake.
Okay.
Once you mix the flour, the sugar, and the eggs and bake it, you can't unbake it, right? That's chemical manufacturing, pharmaceuticals, food and beverage. Discrete manufacturing, on the other hand, is like building a Lego set.
Ah.
You are assembling distinct, countable parts. You can take the tires off a Lego car and put them on a Lego airplane. We are talking about smartphones, automobiles, furniture.
So in discrete manufacturing, you have like thousands of individual moving parts coming from hundreds of different suppliers. The supply chain complexity must be astronomical.
Astronomical is the right word. And that complexity is exactly why the systems buckle under the pressure. The tracking requirements are just immense. But the really staggering number in that Panorama report isn't just the failure rate, it's the cost overruns.
Oh, right. Yeah.
In that sector, cost overruns averaged 215%.
215%. Trying to wrap my head around that scale. If you budget $10 million to digitize your factory's supply chain, you end up spending $31.5 million.
Yep.
And the research from Deloitte and Reuben Brown shows that 50% of these implementations fail on their very first attempt. Most projects exceed their initial budgets by 3 to 4 times. Only about 30% of projects actually finish on time and on budget.
And honestly, the most painful statistic is what happens on launch day.
Oh, go live day.
Yeah, 51% of companies experience major operational disruptions the exact moment they turn the new system on. The moment they go live, the business effectively grinds to a halt.
Which brings us back to that market paradox. You have these catastrophic numbers, this trail of blown budgets and operational chaos, and yet the industry is absolutely booming.
Yeah.
Like Oracle just overtook SAP in 2024 as the #1 ERP vendor by revenue.
Right. They hit $8.7 billion compared to SAP's $8.6 billion.
Yeah. And Microsoft Dynamics is holding around 24% of the customer market share. And then there's the explosion happening in India right now.
Oh, the Indian ERP market is a perfect microcosm of this hungry, aggressive growth. It was valued at $4.5 billion in 2024 and is projected to reach $11.5 billion by 2035.
That's a massive jump.
Huge. And that is driven heavily by government initiatives. Programs like Digital India and Make in India, combined with incredibly strict compliance requirements like their goods and services tax, or GST.
So mid-market manufacturers in India are essentially being forced by regulatory tax requirements to adopt these massive digital systems just to stay compliant.
Exactly. They are adopting them rapidly, capturing a 17.1% share of the global cloud ERP market in 2025. But this massive influx of capital into the space forces us to redefine what a failure actually is.
Right, because it's not a blue screen of death.
No. When an executive says the implementation failed, they are rarely talking about a server crashing or, a bug that requires a quick software patch.
It's not like an app crashing on your phone where you just force quit and restart it.
Right. A failure in this context is defined by a complete breakdown of business continuity. It is defined by massive scope creep, where the project just keeps expanding, adding new features and new integration requirements without any strategic direction.
Just a ballooning mess.
Yeah. But ultimately, and most devastatingly, a failure is defined by a system that forces the organization backward in productivity. The software is installed, the millions are spent, but the company is actually worse off, operating slower than they were when they were using legacy systems or even paper clipboards.
It sounds like buying a state-of-the-art smart home system. You spend a fortune wiring your entire house. But when you try to turn on the kitchen lights, the garage door opens.
Yes.
And the tech company's solution isn't to fix the wiring. Their solution is to just charge you another $100,000 to build a brand new garage that matches the broken code.
That is a brilliant analogy.
But why on earth do businesses keep taking this risk? Like, if the failure rate is over 70%, why not just stick to the old systems?
Well, if we connect this to the bigger picture, the reason they keep pulling the trigger is because the 30% who get it right experience a level of transformation that is almost unbelievable. According to Panorama Consulting, 97% of organizations that successfully implement an ERP report profound improvements in business performance.
Wow.
We are talking about 90% productivity gains, 91% cost reductions over the long term, vastly improved customer experiences because supply chains become perfectly transparent.
The prize is real. It's a genuine operational utopia if you can reach it.
The prize is very real. The executives see those potential gains on the horizon, and they know their competitors are chasing them too. The problem is that the path to get there is just littered with invisible architectural traps.
Right. And to really understand those traps, we can't just look at market data or spreadsheets. We have to look at the real-world casualties. We need to do some diagnostic autopsies of these monumental corporate failures, starting at that Hershey Halloween nightmare in 1999 that we opened with. Let's break down the mechanics of why that $100 million worth of chocolate couldn't move.
So Hershey's objective was necessary. They needed to upgrade their legacy IT systems, they brought in the experts, evaluated the scope, and their recommended timeline to do this properly was 48 months.
Okay, a solid, methodical 4-year plan to replace the digital spine of the company. Seems reasonable.
It was reasonable, but it was the late 90s. The Y2K panic was at its absolute peak. Every board of directors in the world was terrified. Their legacy systems were going to spontaneously combust at the stroke of midnight on January 1st, 2000.
Oh man, I remember that panic.
Yeah. So that external anxiety overrode their internal operational logic. The executive leadership decided to compress a 48-month implementation into 30 months. They shaved a year and a half off the schedule of a massive digital nervous system transplant.
What actually happens mechanically when you compress a software timeline that drastically? Because you can't just tell engineers to type faster.
No, you absolutely can't. What happens is you start skipping the foundational layers of the architecture. Specifically, testing phases are brutally truncated. You skip rigorous load testing, meaning you never actually test if the software can handle the sheer volume of thousands of concurrent users pinging the database at the exact same time.
Just assuming it'll work.
Yeah, and you skip deep integration testing, which ensures the new software can successfully talk to the automated physical machinery in the warehouses. And perhaps most fatally, staff training is reduced to a quick seminar rather than deep procedural habit building.
And then they made the fatal executive error of the go-live date. They flipped the switch in July of 1999.
Which is precisely when they begin receiving and routing the massive orders for Halloween and Christmas.
Unbelievable.
They introduced an untested foundational variable into their ecosystem during their absolute highest stress period. The system couldn't process the orders because the data pathways were clogged, the staff didn't know how to navigate the new error screens, and the physical inventory became completely detached from the digital records.
They totally abandoned Dieter Rams' principle of visual order and methodical process. They forced a complex system into an unrealistic constraint. And they aren't the only giants to fall into this trap. Let's look at Nike in 2001. They invested $400 million in a new ERP and supply chain system.
Yes, and Nike's failure was deeply rooted in a lack of functional clarity, specifically regarding their demand planning algorithms.
Wait, how does software actually predict how many shoes a company needs to make? Like, what is a demand planning algorithm doing under the hood?
So a demand planning algorithm takes historical sales data, mixes it with seasonal trends, marketing spend, and current market indicators, and spits out a forecast. It tells the factories in Asia exactly how many pairs of a specific Air Jordan to manufacture for the North American market 6 months from now.
Okay, that makes sense.
But the software is only as smart as the parameters set by the business.
And in Nike's case, those parameters were catastrophically wrong.
The new software failed to forecast correctly because the people configuring the IT system were completely siloed from the physical business units, the actual retail experts who understand shoe demand. The system caused massive overstocks of shoes that nobody wanted to buy and ordered zero stock of the highly popular ones.
It was a total supply chain collapse. They lost over $100 million in sales, and their stock price plummeted by 20%. It's a terrifying example of what happens when the people building the system don't understand the physical reality of the people operating the business.
Absolutely. But if we want to talk about a failure of basic fundamental logic, the autopsy of Lidl is perhaps the most glaring.
The global discount supermarket chain.
Right. They spent €500 million, over $545 million, and 7 years on a massive ERP project. And after all that time and capital, they just abandoned it. They wrote it off completely.
I am having a hard time buying this. You're telling me a multi-billion-dollar grocery giant spends 7 years and €500 million, and they just walk away?
Walked completely away.
How does a failure of that magnitude even happen?
It comes down to a structural logic flaw. The Lidl disaster was built on a fundamental mismatch between the software's base architecture and the company's physical business operation. Lidl's legacy historical inventory system was built around purchase prices, the prices they paid the farmers and suppliers for the goods.
Okay, so their entire internal culture, their margin calculations, everything is based on what they pay for a can of beans.
Yeah. Right. But the new ERP software they bought, a massive system from SAP, was rigidly configured at its base level to use retail prices, the price the customer pays at the register.
But wait, why couldn't they just go in and change a line of code? Just toggle a setting from retail to purchase?
Because in a system, that massive pricing logic isn't just a toggle switch. It is a load-bearing wall in a skyscraper. The retail price logic was hard-coded into the tax calculation modules across dozens of countries. It was hard-coded into the global supply chain forecasting, into the employee bonus structures, into the daily store-level inventory valuations.
Oh, wow.
Yeah, if you try to rip out that foundational logic and replace it with purchase price logic, you are effectively rewriting the entire $100 million software package from scratch.
So they were trying to force a square peg into a round hole, and the peg happened to cost €500 million. Is this an IT failure, or is this an ego failure?
It is entirely an executive ego failure masquerading as an IT failure. It's the assumption that the software will magically figure it out, or that the physical business will easily bend to a massive logic flaw without any friction.
We see the same thing with Revlon. They lost $64 million in net sales and faced a class action lawsuit because a rollout failure left them unable to fulfill shipments. In all of these cases, the core design principles of Dieter Rams were completely abandoned. Rams argued that good design makes a product understandable. It clarifies the product structure. Better still, it can make the product talk.
But in these enterprise systems, the functional clarity was non-existent. The software was incredibly complex, but the underlying business logic mapping the physical reality to the digital code was fundamentally broken. Which brings us to the hidden bottleneck causing the vast majority of this financial devastation.
Right. We've seen the wreckage. The symptoms are clear. Now we have to diagnose the underlying disease. And based on the research from Luminia Consulting and ECI Solutions, it almost always comes down to what they call the software purchase fallacy.
The most expensive mistake an executive team can make is treating an ERP implementation like they were just buying a basic software upgrade, like they are just renewing a subscription to Microsoft Word and installing it on everyone's laptops.
When in reality, it's not an IT project at all. It is a holistic, foundational business transformation. You are changing the physical flow of work.
Exactly. And the deeptech analyst Prasad Bhan uses a brilliant architectural critique to explain this disconnect. He calls it the MRI machine as a coat rack.
I love this metaphor. Let's unpack the mechanics of this because I think it perfectly captures the absurdity of what happens in these boardrooms.
Okay, so imagine executive management decides they need to modernize the business. They want that 90% productivity gain. So they go out and buy a $100 million out-of-the-box enterprise system. This system has been designed by thousands of top-tier engineers over decades. It has optimized, highly efficient, standard workflows built right into its base code.
It is the MRI machine. It is highly calibrated, incredibly precise, and designed to do one complex thing perfectly.
Exactly. The software arrives at the company, but then the department heads, the VPs of operations, the regional logistics directors, they look at this optimized digital workflow and they panic. Not just panic, it's actually self-preservation.
Right, their jobs are changing.
Yeah, they realize this new software requires them to change their physical daily routines. It requires them to abandon their comfortable spreadsheets, their legacy processes, the unique little quirks that make them feel essential to the company.
So they aren't just using the MRI machine as a coat rack. They're actually paying engineers to weld extra hooks onto the MRI machine, which voids the warranty and completely breaks the magnets.
That is exactly what happens. Instead of adapting their physical operation to fit this highly optimized software, they demand that the implementation team write heavy, expensive custom code. They force the engineers to bend the new system to perfectly mimic their old, inefficient analog processes.
They digitize their own gridlock.
They create a highly expensive, deeply fragile digital clone of a broken analog system. And let's explain why custom code is so dangerous from an architectural standpoint.
Please do.
Base code is stable. When the software vendor releases a global security update or a new feature, it applies seamlessly to the base code. But custom code. Custom code is technical debt. Every time there is a global update, your custom code breaks. Your welded-on coat hooks snap off, and the machine crashes.
Think about your own office right now for everyone listening.
Sure.
How many times this week have you exported a perfectly good automated software report into a messy Excel spreadsheet just because that is the exact format your boss has liked reading it in since 2015?
Oh, all the time.
That exact instinct, the refusal to adapt to the cleaner workflow, is what costs these corporations billions of dollars.
Dieter Rams' core principle of reduction states, good design is as little design as possible. It concentrates on the essential aspects, and the products are not burdened with non-essentials. Back to security, back to simplicity.
So if we apply RAMs to enterprise software, the solution isn't to hire more consultants to write more custom code to fit a bad physical habit.
The solution is the exact opposite. You have to aggressively strip away the custom code. You have to enforce functional clarity by forcing the physical business operations to standardize to the software's uncustomized base code. You have to change human behavior, not the software.
But changing human behavior introduces a massive amount of friction. And when the executives force that custom code through to protect their own comfort, who actually absorbs that friction? When the system inevitably freezes under the weight of all that technical debt, who pays the price?
The human beings on the floor, the frontline workers. This brings us to the human factor, which research shows is the single biggest cause of ERP failure. Change management, or the lack thereof, contributes to over 42% of these failures.
Almost half of these multi-million-dollar disasters fail because of human psychology, not technological capability.
Technology doesn't resist change. Human psychology does. When organizations obsess over software configuration but completely ignore the daily reality of the people who actually have to use it, system adoption crashes.
We need to paint a vivid picture of what this looks like in the operational trenches, because the CEO is sitting in a boardroom looking at a dashboard with a red error light. But the physical reality is brutal. When a hospital's highly customized data system gridlocks because it was forced to act like a legacy paper system, the patients don't stop arriving.
Exactly. The charge nurses, the warehouse supervisors, the logistics managers, they take the hit. They are the ones working 14-hour shifts to manually route data. They are running manual workarounds on physical clipboards just to keep the global infrastructure breathing.
That's terrifying.
They are handwriting routing numbers on patient charts with a ballpoint pen while a $100 million software system spins a loading wheel.
That is the silent, undocumented labor of the modern enterprise. And Prasad Banda's concept of restorative engineering demands that we actively validate this labor.
Right. By normalizing the fact that these multi-million-dollar systems are fundamentally flawed in their implementation, we disarm the operator anxiety. We bypass the crab mentality.
What exactly is the crab mentality in this context?
So if you put a bunch of crabs in a bucket, anytime one crab tries to climb out, the others will pull it back down.
Right.
In a corporate environment, when a new system is introduced, departments fight each other over who gets to keep their legacy workflows instead of working together to fix the core architectural issue. Everyone is pulling each other down to protect their turf.
And a major driver of that anxiety is that the frontline operators are almost universally excluded from the user interface design phase. The people who have to actually click the buttons to ship the pallets are never asked where the button should be.
The Chief Information Officer treats the deployment as a top-down IT installation. They don't view it as a collaborative workflow design. The UI becomes a cluttered mess of non-essential navigation steps, causing deep-seated anxiety and creating massive long-term barriers to system adoption.
Okay, I have to challenge this logic for a second. If you are a CFO, you just signed a $50 million check. The warehouse managers clearly know the system is broken, right? They're literally using clipboards to bypass it. How does a massive corporation miss something that basic? Why isn't that feedback reaching the C-suite before a $500 million write-off occurs?
Because of the feedback vacuum. In these massive corporate hierarchies, bad news rarely travels up unedited. The metrics for success are fundamentally misaligned. The C-suite is looking at a high-level digital dashboard. They see a green light indicating that the software module was successfully installed by the IT department.
So the IT director hits their KPI, they get their annual bonus, and they report a massive success to the board.
Exactly. But down on the warehouse floor, the frontline operator is staring at a screen that now requires a 40-step navigation menu just to ship a single pallet, something that used to take 3 steps on the old system. The software is technically installed, but the physical operation is bleeding efficiency.
That's just wild.
The executives measure success by asking, did we install the software on budget, instead of asking, did we restore or improve human capability?
Wait, if these operators are doing manual workarounds on clipboards and navigating 40-step menus, what happens when they finally type that delayed information into the system? The data moving through that system must be completely disconnected from reality by that point.
It becomes deeply corrupted, and this is where we see the absolute lifeblood of the ERP system fail. Data migration in an ERP implementation is often treated by executives as a simple IT copy-paste exercise. Just move the files from folder A to folder B. But it's not. Data migration is a physics problem.
A physics problem. Break that down for me.
If you are moving massive amounts of matter, in this case decades of historical business data, from an old, analog, or flat file structure into a highly structured relational database environment, you can't just dump it in. A relational database requires specific formatting, specific linkages. You have to map the physical reality of that data to the new operational logic of the software.
There's a chilling example in the sources from ECI Solutions that highlights exactly how this hidden complexity ruins implementations.
Yes. A manufacturing company went through a massive implementation. They survived the launch, they went live, only to discover that their core inventory data was entirely corrupted.
And it wasn't just a formatting glitch where a dollar sign was missing. It was operational reality versus digital fiction. Products that the system marked as available literally did not exist in the physical warehouse.
Yep.
And products marked as discontinued in the new ERP were actually their highest volume, most profitable best sellers.
The ERP software itself was working perfectly. It was calculating exactly what it was told to calculate, but it was processing garbage data. Garbage in, gridlock out. It made accurate reporting or physical logistics completely impossible.
The financial impact of that is staggering because it's not just an IT headache for a weekend. If your system thinks your bestseller is discontinued, your purchasing department stops ordering the raw materials to make it. You stop manufacturing it.
Ridiculous.
Suddenly, your sales team is on the phone telling your biggest, most loyal clients that you can't fulfill their orders.
You alienate your core customers. Conversely, you fulfill orders for ghost inventory that doesn't exist, leading to massive shipping delays, angry retailers, and financial chargebacks. And internally, it rapidly erodes all trust in executive leadership. When the frontline staff sees a system that is fundamentally detached from physical reality, they abandon it entirely. They go back to the clipboards.
So how do we solve the data migration physics problem? Do we just hire armies of data entry clerks to manually verify every single digit?
No, you apply Dieter Rams. You design minimalist software workflows for these data tasks. You simplify the core workflows by ruthlessly stripping away all non-essential software navigation steps. You enforce functional clarity.
Less but better.
Data migration requires a hard, uncomfortable audit of what information actually matters to the future of the business. You have to aggressively discard the rest. If an old data point, say a highly specific internal tracking code used by one regional manager 5 years ago, doesn't serve the new optimized workflow of the base software, you kill it.
You just let it go.
You do not write custom code to preserve it. You do not migrate it. You let it go.
That requires a level of executive discipline that seems completely missing in these 75% failure statistics. So we've diagnosed the disease, we've seen the human cost of digitizing broken workflows, the silent labor on the front lines, and the financial devastation of corrupted data. Now we need the cure. We need a concrete architectural solution that executives and operators can actually use today to stop the bleeding.
This is where Prasad Bandey's concept of restorative engineering provides a blueprint. The core mandate of restorative engineering is a philosophical shift. Technology must not just be installed for the sake of modernization. It must actively restore human capability, safety, and dignity.
It's shifting the focus entirely from the software's feature list to the human being's physical reality.
Yes. And the mechanical process to achieve this is what he calls the 48-hour protocol. It's a method for actionable, localized validation.
Let's get into the 48-hour protocol, because it sounds a hell of a lot safer than a 48-month rollout that gets compressed into a Halloween disaster. How does it actually work?
Well, the traditional model is a massive, multi-year, company-wide rollout where everything goes live at once. It's too big to fail, which means when it fails catastrophically across the entire globe simultaneously.
Right.
The 48-hour protocol forces a localized, highly controlled test. You take one single, uncustomized, base-level software module.
The pure, out-of-the-box MRI machine. No extra code hooks welded on.
Exactly. You strip away all the non-essential features, you deny all the custom code requests from the department heads, and you run it in just one department for exactly 48 hours.
And what are you measuring during that window? Because it can't just be a survey asking if the employees enjoy the new colors on the screen.
No, you do not measure sentiment. You rely strictly on physical, raw data to prove the efficiency gains. You measure the exact millisecond latency of the software screens loading. You measure the physical error rate of the data entry or the pallet shipments. If the uncustomized base code processes the physical movement of goods faster and with fewer errors than the customized legacy process, the data wins.
You let the objective physical data dictate the rollout, rather than the emotional attachment to old habits. It proves to the stubborn VP of operations that the standardized way is actually faster.
Correct. Process must dictate architecture. The physical movement of goods and data must dictate the software input, not the other way around.
If we are doing all this, if we are testing locally, stripping away custom code, interviewing the frontline, it completely changes how a CEO or a CIO gets their bonus. We can't just measure, did we launch on time anymore?
Yeah.
So what does the new executive checklist look like? What is the leadership roadmap to prevent a billion-dollar failure?
We can synthesize a 4-point checklist based on all this research in RAM's design philosophy. Step 1. Stop treating ERP as an IT project. The Chief Information Officer cannot be the sole owner. It must be treated as a holistic business transformation, sponsored actively by the top executive level, the CEO or the executive board.
Because it requires the raw operational authority to force behavioral change across the entire company, not just IT compliance.
Exactly. Step 2. You must interview the frontline operators. Do not rely solely on managers. Go to the warehouse floor. Talk to the charge nurses. Identify the hidden daily workflow friction points that never make it onto a polished executive dashboard.
Ask the people using the coat rack why they're hanging coats on it.
Yes. Step 3. Implement asynchronous extraction. When there is a bottleneck, cancel the endless alignment meetings where everyone just talks in circles to protect their turf. Instead, require the frontline operators to draft a 150-word text brief identifying the exact system blockage.
What is the significance of the 150-word limit?
It forces what we call Feynman compression. Richard Feynman, the physicist, believed that if you couldn't explain something simply, you didn't understand it. A 150-word constraint breeds clarity. It forces the operator to reduce the complex mechanism to its absolute simplest operational truth.
Oh, that makes total sense.
And it forces the C-suite to make a binary yes or no decision to fix that specific block. It eliminates corporate fluff and focuses entirely on functional clarity.
And that leads into the final step, which has to be redefining the metrics of success.
Step 4 is redefining success beyond traditional project budgets. You have to measure true project success by user efficiency. Measure click reduction. Measure how quickly operator adoption rates increase when you remove software clutter. If a process took 12 clicks and now it takes 3, that is a success metric.
Think about how this applies beyond a massive global logistics team. Even if you're just trying to adopt a new project management tool for your small business or organizing your own personal hard drive, the lessons are identical. We often buy shiny new productivity apps thinking the software itself will magically cure our procrastination or untangle our messy workflows.
We really do.
We think the tech is a magic wand, when really the tech is just a mirror. We actually just need the discipline to change our own daily habits, to standardize our processes to fit a simpler, minimalist design.
It is true at the personal level, and it scales all the way up to the enterprise level. A $112 million software rollout will never fix a broken physical process. You cannot fix a bad habit by digitizing it.
The numbers don't lie. 70% of these massive ERP systems fail. And they fail primarily because we refuse to change our physical habits, effectively forcing brilliant software to act stupid. We force it to mimic our worst inefficiencies. The true key to a successful digital transformation isn't writing better custom code. It is radical human empathy for the frontline worker who actually has to use the system, combined with a rigid, almost ruthless adherence to Dieter Rams' minimalist design philosophy. Functional clarity. Less, but better.
We spend billions upon billions of dollars trying to make enterprise software think like a human. But the real trillion-dollar question we have to ask ourselves is, when will we realize that building a truly functional, world-changing system requires us to simply sit down, be quiet, and actually watch how a human being does their job?